Friends, the graphical view of continuity of functions. Friends, if you are new here, please subscribe the channel and see the complete video for a proper knowledge. Okay, we have drawn here 4 figures. Figure 1, figure 2, figure 3 and figure 4. Okay, one by one we shall discuss. First of all, figure A. Let us consider that this point B x is equal to A. Okay, at this point observe that the RHL and LHL. Okay, first of all, what is LHL? LHL means left hand limit. LHL is this one, this height we consider that this be L1. Okay, so LHL is standing to L1. LHL is standing to L1. That means when x is standing to A negative, this is LHL, A negative, then on the curve also fx is standing to L1. So LHL is standing to L1 and RHL is standing to, when x is standing to A positive, that means from right side of A, then on the curve also fx is standing to this point and this height is, consider this is L2. So RHL is standing to L2. Here L1 and L2 are not equal. One thing is important, friends, see that fa is the function fx at x is equal to A exists. Okay, that means fa is defined. Here since LHL is not is equal to RHL, therefore the limit does not actually exist. Since the limit does not exist at the point x is equal to A, so the curve y is equal to fx is not continuous at the point x is equal to A. Friends, we now go to the second figure. The second figure is, consider again this point B, x is equal to A, this point. Okay, so we shall now draw the LHL and RHL both. Okay, so when x is standing to A negative, then the function, on the function also fx is standing to this height. Consider that this height is L1. Okay, we consider it L. When we are proceeding to x negative, x is standing to A negative, then fx is standing to L. Okay, so LHL is standing to L. On the other hand, when x is standing to A positive, x is standing to A positive, then on the curve also fx is approaching to L again. So LHL is also proceeding to L. So here you see that LHL and RHL both are equal, L and L. Now one thing is very important. LHL, RHL are equal, but FA does not exist here. FA is not defined here. That means fx is not defined at the value x is equal to A. For this, the function is not continuous. The first one also not continuous. Second figure is also not continuous. Now we shall go to the third figure. In the third figure also, we again consider this point, say this is x is equal to A. So friends, here when x is standing to A negative, this is y is equal to fx, this is the curve actually. When x is standing to A negative, that means LHL, for LHL, the function fx is standing to this height. Okay, this height. Let us consider that this height be L. Okay, this height is L. Up to this part, this height is equal to L. So LHL here, LHL is standing to L. And when x is standing to A positive, then on the curve also fx is standing to L again. So RHL is tending to L. So friends, LHL and RHL both are equal. So the limit exists. And one thing is important, FA is also the value of fx at the point x is equal to a. That means FA is also defined here. This is FA. But one thing is important here, that LHL is equal to RHL, but it is no way equal to f of a. This is not is equal to f of a. For this function is not continuous. This is also not continuous at x is equal to a. At the point x is equal to a, the function is not continuous. Third figure also, you see, in the third figure also, LHL, RHL both are equal. That means limit exists, but FA was not defined. For this function also not continuous at the point x is equal to a. In the first figure also, you see that LHL and RHL are not equal. LHL tends to L1 and RHL tends to L2. Since LHL, RHL are not equal, for this limit does not exist. When limit does not exist, then the function is not continuous at the given point, that is x is equal to a. And finally, we go to the final figure. This is figure number 4. We consider that this point x is equal to a. Okay. So friends, for the LHL, okay, we consider the LHL. Now LHL, that means when x is tending to a negative, then the function fx is also tending to this height. Okay, this height, we consider that this height be L. So LHL is tending to L when x is tending to a negative. On the other hand, when x is tending to a positive, so in this case RHL, that is fx, is also tending to this height, and this is again L. So RHL is tending to L. So since LHL and RHL both are equal, for this limit exists. Okay. So friends, we write this one. This is important step. LHL is equal to RHL. Both are equal to L. And another thing is, you see that this is dark circle. That means the function fx is defined at the point x is equal to a, and this is f of a. Okay, so LHL is equal to RHL and FA is equal to L. These two heights are also equal. So this is equal to L, this is equal to FA. So obviously we can write LHL is equal to RHL. RHL means right hand limit, LHL means left hand limit. These are equal to f of a. That is the value of the function fx at the point x is equal to a. Friends, since limit exists and the limit is equal to f of a, for this function fx, this is y is equal to fx, fx is continuous at x is equal to a. Thank you. Have a nice day.